So we're gonna talk about Lewis dot structures, which is a way to picture all the valence electrons. You might also run into electron dot diagrams, like I don't know what they call it on Khan Academy, but if you're looking for extra videos and you see electron dot diagrams, that's the same thing. Just calling them Lewis structure gives credit to the gentleman that developed it. What is his first name? I should tell you. Let's give credit to probably Dr. Lewis. Gilbert N. Lewis, professor of chemistry at the University of California at Berkeley in the early 1900s. He developed this model. Some Khan Academy videos would be helpful. I've been meaning to look in there and see. Maybe I'll have those links up by the time you're listening to this, just to add if he has some video lectures or some information about these same topics. I think he has a really profoundly good way of explaining things often, and sometimes just hearing it from another person said just a little differently. They may just say something just so that you're like, oh, that's what you're talking about. So if I can find some links to these specific topics, because I'm pretty sure they have chemistry on there, that might be really helpful. So I will look for that. If I get time before we leave Saturday, hopefully. I'm trying to get a whole bunch done. It's a little bit crazy, which is not your fault, so I want to try to get that for you. But if I don't, you certainly can look for it. So Lewis structures, or electron dot diagrams. So we're going to use dots around the name of the element to represent the valence electrons. So at the very beginning, my eraser go. This is pretty basic. Well, where did it go? One sec, guys. I swore I brought it over here, but I think I did. I just dropped it over here. One sec. Okay, so we're going to start out by writing down the name of something. Let's start with an easy one that gives the example of lithium. So I'm going to write down Li for lithium, and then I'm going to look on my chart, and I'm going to look for lithium. All right, lithium is in column 1A, so it has one valence electron. So I'm just going to put one little dot right out here to the right of lithium, and that represents that one valence electron. Pretty easy, right? Okay, so what do we do when we have more than one valence electron? Let's take a look at something like carbon, okay? So carbon is over here in 4A. So carbon has 4 valence electrons, right? So I'm just going to write down a C for carbon, and my first dot is going to go out here to the right. Then I put one down here for 2, one down here for 3, and one up here for 4. So that's how I demonstrate those 4 if I have more than 4. So if we have fluorine, that has 7. Fluorine's over here, remember in that column 7. So it has 7 valence electrons. Nothing crazy here, right? So I'm going to write down the F for fluorine, and I'm going to put 1, 2, 3, 4, and then I'm going to start over again here. 5, 6, 7. Oops, it only has 7. It's not a noble gas. It's just getting going there. So it's just filling in 1, 2, 3, 4, and then just starting over as you go. And then, so as you might expect, a noble gas is just going to have all those filled in. So if I had like argon, something like argon that has all of them filled, it's just 1, 2, 3, 4, 5, 6, 7, 8. And it just looks like that. That's all that Lewis dot structures are. Now we're going to do more complicated things with them, but as a start, that's all that's going on. So now we get to look at some cool stuff, okay? The stuff that's coming up in this module, my brain was kind of spinning, I will admit to you. Not so much with these Lewis structures, although still makes your brain work a little. We get into some more complicated covalent bonding, and it's a little like, what's happening here? And I had to work on it a bit, I will tell you. I was not coming back to me as quickly as I had hoped, but I think I'm getting there. And so there's a lot going on in this unit too. It's not really math, not so much math like the other one, but just thinking, thinking and problem solving a bit. So you'll get it. You'll have to probably practice. You'll probably have to practice a bit. So I say that so you're not discouraged. Like it was hard for me too. I had to kind of think through it, and it's kind of like solving. If you're a puzzle solver and you like puzzles and riddles, you probably will like it, or like Sudoku or whatever they're called, puzzles. You might like this a little bit. We're not getting into it as much in this video as the next. Well, I may add it. We'll see. I'm sitting here wondering if it'll be enough for you to work on, but I'd rather maybe have a little less and just get it down solid because I plan to do Unit 4 over 2 weeks' time anyway, so that'll give you time to work on your homework together, so we'll probably keep it just at this. Okay, sorry, I'm thinking out loud. I do that a lot. Okay, so now we're going to look at something. We are going to look at ionic compounds. So if you recall, ionic compounds, and I'm on page 136. I'm going to be referencing stuff on page 136 if you want to be looking at it. Ionic compounds are bonds between metals and nonmetals, right? And they can only come together one way, and you'll kind of see why that is. Okay, I just said that, and I was thinking about what I was saying. Okay, so we're going to look at sodium and chlorine, okay? Okay, I'm saying okay a lot, sorry. So sodium has, look at your chart. I want you guys to have your periodic table out. Look at it. When I say sodium and I say it has this many valence electrons, you look at it too and make sure you agree. Make sure you know how I'm getting that number. Sodium's in the first column, 1 valence electron. So I'm just going to draw that little dot out to the right. And then I have chlorine, which is over here. I know it's in column 7 because I've already looked at this, but it's in column 7. So it has 7 valence electrons. And so I'm going to draw those in. So 1, 2, 3, 4, 5, 6, 7. Okay? So that's how chlorine's going to look. So chlorine is really close to that ideal structure, right? And sodium needs a lot of electrons to get there. So it would be easier for sodium to give up an electron to get stable. And chlorine is really wanting an electron to get stable. That's where they're at. That's what they're trying to do. Sodium would never try to get 7 electrons. It would take too much. It would be too difficult. It's so unlikely to happen. We would have to create some sort of forced scenario to make that happen. I don't even know if chemists do those sorts of things. But just in natural chemistry, sodium wants to gain 7 electrons. Wants to lose an electron. And then it's stable because now it's got a full octet below that as far as its valence electrons. And then chlorine wants to gain 1, so it can have 8. So as we look at that, chlorine and sodium can bond together by sodium giving that electron to chlorine. Okay? So that's going to then look like this. Wait, actually, does it look like that? Let me double check. I want to be careful how I draw it, and the reason is because I think I'm starting to draw it like a covalent bond, and I don't think we do that with, as I'm looking at it, I don't think we do that. What happens, so here's the difference. In ionic bonds, they actually give up their electrons. Sodium is actually going to give its electron to chlorine, and chlorine's going to take that, and they're going to actually change, and they're no longer going to be sodium and chlorine. They're going to turn into ions. I'll explain that here in a second. In covalent bonding, which we'll learn about later, did we get to that today? Let me double check. I don't think we actually do. No. We'll get to covalent bonding later. But they share the electrons rather than just giving them up. So if it's a covalent bond, they'll just kind of share one of those electrons. So sometimes it's kind of zooming around and it's around the one, and sometimes it's zooming around and it's around the other. They're sharing it. But that doesn't happen with ionic bonding. They actually turn into ions. So when sodium gives up its electron, think about it. Sodium has an atomic number of 11. That means it has 11 protons and 11 electrons. So if sodium suddenly, let's write that down, suddenly gives away one of its electrons, that's 11 electrons, it's kind of strange. If it gives away one of its electrons, now it has 10 electrons, right? So now it still has 11 protons, but now it has, let's just put positive and negative so you can see what those are. But now it has 10 electrons. So its overall charge is positive. It becomes a positive ion. We'll give that a name in a minute. So sodium, as it gives up its electron, becomes a positive ion. I want you to remember that. There's just lots of words here to remember in this unit. And chlorine naturally has 17 protons and 17 electrons. So if suddenly chlorine gains an electron, now it has 17 protons and has 18 electrons. So now it has an overall negative charge, right? So it's going to become a negative I'm teaching chemistry here. You can just sit and listen and hear it now and hear it again in a week.
What else did I say during the videos?
Here, I'll pause it real
Oh,
quick.
hello, chemistry class.
Wait, I thought I paused. You guys are so silly. Anyway, yes.